Hi students, welcome to the next topic from gravitations, and we are going to discuss many things today. So write down the first heading, gravitational field intensity. The next heading, gravitational field intensity. Gravitational field intensity for a solid sphere. For a solid sphere. Gravitational field intensity for a solid sphere. So what is a solid sphere? Solid sphere is something like, normally we are using the shot put ball in sports, right? What is that? It's very heavy. It's very heavy, which means it is made up of some iron kind of material, and inside it is fully filled with iron. Outside also it is iron. It's iron material and it's very fully packed stuff. So that is called a solid sphere. Inside it is not empty, inside it is filled with some material. Okay, so we are going to find out gravitational field intensity for a solid sphere. Solid sphere, we are going to locate 3 points: inside, surface and outside. Pakka. So let's have a solid sphere. On board will be here. So we have a solid sphere. And its inner point, we are going to calculate the gravitational field intensity E here inside at a distance of r distance away, and surface at a distance of capital R, and outside at a distance of E outside and E surface. This is also R. We can consider this as R dash, this as R. So there is no confusion. R dash, R and small letter R. Now we are going to find out gravitational field intensity inside. We are going to find out gravitational field intensity inside. To find out gravitational field intensity, we will consider a small circle, and that circle surface belongs to this point, red point. Here red point, this is a surface point, and this is belongs to the black circle. So what is the general expressions for gravitational field intensity? Gm divided by r square. Let me assume the mass of the bigger sphere is m. Okay, which means that 4 by 3 pi r cube area. This is the volume of this cube. This cube will have m kilogram weight. This is this much meter cube. Meter cube is the volume. Both the sides I am dividing with the 4 by 3 pi r cube. So what should I get? 1 meter cube give rise to m divided by 4 by 3 pi r cube is the 1 meter cube. 1 meter cube എടുത്തന അതിന്റെ mass എന്നുള്ളത് m divided by 4 by 3 pi r cube. What is our volume will be here? This is our small sphere. What is the volume of this one? The volume of the sphere is 4 by 3 pi r dash cube. Which means I am multiplying left hand with 4 by 3 pi r dash cube. So right side I have to multiply. So m divided by 4 by 3 pi r cube into 4 by 3 pi r dash cube. 4 by 3 pi, 4 by 3 can cancel. Which means mass of the smaller sphere marked will be in the black color, will have a volume of 4 by 3 pi r dash cube. That is the volume of this cube. Volume of the sphere, right? Exactly. So what is this one? M into r dash cube divided by capital R cube. This is the mass of this segment. So mass of this one, mass of this is equal to how much? Capital M into R cube into R dash cube. Now this is what we have calculated. Now we are substituting. So E inside. This is a general equation. Now we are come to inside. So inside point G into mass. What is the inside mass? This black color mass. G equal to M into capital R cube into R dash cube whole divided by denominator r square. R is the distance from here to here. The distance is what? R dash square. So get cancels, 1 r dash square, both numerator denominator cancel. We got gm r dash whole divided by r cube. This is the gravitational field intensity inside a solid sphere. So this is very important. Gravitational field intensity inside a solid sphere, GMR dash divided by r cube, where r dash is the inner radius. Okay. So that is also clear. Now we are going to see what is the other things. What is the other thing? Gravitational field intensity. We need to find out the gravitational field intensity at the surface location, and we need to find out the gravitational field intensity at which locations? At outside locations. So let me go here. Okay. So we will write. So inside is over. The next point is at surface. So at surface. So gravitational field intensity inside, gravitational field intensity surface, and gravitational field intensity outside. So again we have this general equation Gm by r square. So now we are writing at surface. So surface is equal to, I will use the same color, right? So that we have the same equation is available. Same equation means the same general formula is available with us, but this will be changes to ES will be equal to G into, what is this surface? Surface means the full sphere will come, which has the full mass, divided by its distance, means r square. Okay. Now we are going to see the next part. What is the next part? It's outside position. So outside position. So gravitational field intensity for a sphere which is having outside. Outside means we are considering this set. So outside means this sphere. So for the whole sphere, here it is empty. Nothing, gas, nothing will be there. Here is empty piece. Vacuum area. Okay. So here nothing will be there. It's fully gas medium is available. So here it is fully solid medium. So what is the mass of this one? Mass is equal to again m divided by distance from the center to this point r. So E out equal to Gm divided by small letter r square. Okay. Now we'll see the graphical representation. Graphical representation. What is a graphical representation for this one? Inside and outside and surface. So with respect to the distance r, E. So when we are at the center, r dash will be equal to 0. So gravitational field intensity at center is equal to 0, because r dash will be equal to 0, because r dash equal to 0. So at the center this will be equal to 0. When r dash increases, because we are going from the center to the outer area, when this will be increases, when r dash increases, what will happen to E in also increases linearly. So I can write E in proportional to r dash. Now we have reached on the surface. When we reach on the surface, r dash is equal to what will come? When r dash is this distance, when we reach to the surface, r dash is equal to r. When r dash is equal to r means r and r get cancels. It becomes Gm by r square will come. So now this is a surface point. So now you reach on the surface where r dash equal to capital R. After the surface, now we are at the surface. If you are moving away from the surface, what will happen? This r will be increases. If this r will be increases, what will happen to the out? E out will be reduces. So it's not a straight line, it's a quadratic equation, right? With a power equal to 2. So it's a parabolic in nature. So E out proportional to 1 by r square. Make sure that it is a parabola, because it is a square equation, quadratic nature. Parabola will come in quadratic equations, right? So here it is a straight line equation, because E in proportional to r dash. Y is equal to mx plus is straight line equations format. So E in proportional to r dash, E out is proportional to 1 by r square. This is the graphical representation of the variation of gravitational field intensity in a what sphere? Solid sphere. Okay, remember this topic, it's very, very important. Okay. So one more point I would like to take into account. Gravitational field intensity of a hollow sphere. Gravitational field intensity of a hollow sphere. Okay. So gravitational field intensity gravitational field intensity for a hollow sphere. Hollow means what? Inside it is empty. Okay, I'll just giving a recap. So inside gravitational field intensity is what? 0, because there is no mass, nothing is involved. Gravitational field intensity at the surface is gm by r square. Gravitational field intensity at a distance of r out, this is surface, and E outside is gm divided by r square. R here capital R, because that is the radius, here it is r square. Within the sphere no mass is involved. In short, so gravitational field intensity is equal to 0 for a hollow sphere. Hollow means here it is empty, nothing. Surface we have value this one. So we'll see the graphical representations. What will be the graphical representation for this one? Graphical representation. Whenever mass will be there also, the gravitational field intensity, here there is no mass, so simply we can say E equal to 0. Once we consider this point involves a mass, so this is valid. Once you consider an outside point like this, so within this point any mass? Yes, so gravitational field intensity is exist, in short. That's in a simple way to remember. So we'll draw the graph. Okay, what's the difference will be here? Gravitational field intensity inside 0, surface will have a value, and outside it is going 1 by r square format. This is what? This is the surface point. This is inside. Inside it is equal to 0. This is the E axis, this is a distance axis. So what I want to know means, what I'm trying to compare the gravitational field intensity for a hollow sphere. Graph is like this one. Okay, for a solid sphere, what is a graph? Graph, the first part is a straight line. That is the only one difference. Solid sphere, first part is a straight line. Hollow sphere, inside it is 0. Just remember this one. Okay, graph is important. Graph as such will ask for your entrance examinations in general. Okay, so these two are important, especially the graph and the equations. Only you have to remember solid sphere. Apadi question irundana 3 equations you have to remember, 1 graph you have to remember. Hollow sphere, 3 equations you have to remember, 1 graph you have to remember. So from the 2 topic, 3 plus 3 totally 6 equation with 2 graph. Write the next heading: acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity. Acceleration due to gravity is representing using a letter called G. What is called acceleration due to gravity? From small class itself we are learning. This is an earth. We'll assume this is an earth, and I am standing in the surface of earth. What will happen? I am attracting towards the center of earth. Okay, I am attracting towards the center of earth, which means that my weight, my mass is called m. So I am attracting towards the center of the earth. So my force which is attracting towards the center of earth will be equal to earth in the mass capital M, earth in the radius r, mass m, earth in the radius r. Some textbook m in r in. Okay, that is doesn't matter. You can use it whatever it is. M-E you can use it, M you can use it, R you can use it, R-E you can use it. All are same, pakka. So a weight is coming down, which means a force is coming down. What is the force between two particles? Newton's law of gravitation. That is what kind of force? Attractive force. So F is equal to, tell me the formula. F is equal to, what will come? G into M1 M2, M into small letter m. Two masses, earth and my mass, divided by distance between them is r square, is equal to weight of a body, force is equal to mass into acceleration, mg. M and M will get cancelled. You got one term which is called G. G is equal to Gm divided by r square. Very, very important. Very, very important. So G is equal to Gm by r square. Acceleration due to gravity of a body is equal to Gm by r square. M is the mass of earth. M is the mass of earth, R is the radius of earth. Radius of earth. It is not depends upon any other factors. It is only depends upon the mass and it is only depends upon the radius. This is one way. Or some textbook, as I told before, you can also write it as GME, or they will written as RE square. Both are same, 1 to 1 same. So ME bar M or R bar RE. Both are it is same, there is no difference between them. Mass of the earth is a standard value 6 into 10 power 24 kilogram. This is 6,400 kilometers. These are the some standard values. If you are remembering, you can remember 6 into 10 power 24, 6,400 kilometers. In case if question is not specified, it is good to remember this value. If you substituted the values over will be here. That means what all the values will be there? What is the value of G? 6.67 into 10 power minus 11 is the value of G. G is called universal gravitational constant. Okay, so G is called universal, already we told, right? Universal gravitational constant. Okay, it is fixed everywhere. You can write it is fixed everywhere. Everywhere it is fixed. It is fixed everywhere, not depend on any factor. Not depend on any factor. It is not depends upon nothing. It's constant. Constant means constant. So 6.667 into mass 6 into 10 power 24 kilogram. Radius in the square. This kilometer and meter load convert. So how to convert 6,400 into 10 power 3 kilometer to meter, RE square. Then solve here, you will get an approximate value 9.8 meter per second square. This in standard, while we are solving the problem, we are consider this as 10 meter per second square. Very important. This we consider as 10 meter per second square. Okay, pakka, super. So acceleration due to gravity, it's very important. Under this one, we have 4 different topics are available. We have to see one by one. Okay, so let's go. Let's go. The first one. We have, as I told, 4 topics will be there. What are the factors like the acceleration due to gravity is depends upon. So based on that, we have 4 things will be there. Okay. So first we will just summarize the 4 points, then we'll go a very detailed analysis of one by one. Okay, so the first one, you can write the main heading, variation of G. Variation of G, first one. Variation of G, first one, due to height above earth surface, second one, due to depth below earth surface, second one, due to shape of earth. D has to write capital, right? That is a standard English structure, so we will follow that. Okay, super. So due to the shape of earth, and finally what is the due to the rotation of earth, Paka. So 4 points we have. We are going to find out the variation of acceleration due to gravity based on the 4 factors: due to the height above the earth surfaces, due to the depth below the earth surfaces, which means the acceleration due to gravity is changing if you are going above the earth surfaces, if you are going below the earth surfaces towards the center, and due to the shape of the earth, acceleration due to gravity changes, and due to the rotation of earth, we know earth is rotating, right? Earth is rotating. So due to the rotation of earth, gravitational field, the acceleration due to gravity is also changing. Now, a simple questions to you. What is the difference between acceleration due to gravity and gravitational field intensity? Both are equation wise look same. See, G is equal to Gm divided by R square. Here M is a mass and R is the radius. Both are related to Earth only. But gravitational field intensity is Gm by R square. This is for any mass at any distance. Okay, equation wise both are look similar, but the concept wise both are different. Acceleration due to gravity, G is depends on the mass of Earth and radius of Earth, important. But gravitational field is intensity is depends upon the mass you have considered, it's a solid sphere or hollow sphere, like that. So whatever you consider, that mass is taken into account here. And the distance where you are calculating the gravitational field intensity, that point, that distance from where center to that body center to that distance is called gravitational field intensity distance, and the mass of the body is will be here called m. But in case of gravitational field intensity, it is not depends on any other factors. It depends upon the mass of the Earth and the radius of the Earth. Very important. Note down these two equations and make sure that you know this in very clear way. Okay. So that's all. Fine. Perfect. So we see like 4 heading. There are 4 ways the acceleration due to gravity can change. And one by one we will see how these are affecting or how these are going to change for a gravitational field intensity. Okay, so let's start with the first one, the variation of the gravitational field intensity due to height. So right on the first heading we have 4 headings are will be here. First one, variation of G due to what? Variation of G due to variation of G due to what? Variation of G, variation of acceleration due to gravity, due to which? Due to variation of acceleration due to gravity due to height. From where? Height is from where? Height is above the surface of Earth. So I know. Okay. So we'll draw a couple of diagrams and we'll see. So let me make it. So we have a circle like this one. Okay. So I have this Earth having mass m and radius r. Okay. Let me keep it height in the sense like. So this is called r and whose mass will be equal to m. I am going at an height of h above the Earth. So at this point here, I know G is equal to Gm by R square. What is G dash at this point? That is what we are going to calculate. G dash at a height above the ground surface, what is the value of this one? Okay, so let's have this one. G dash will be equal to Gm divided by. So mass, so if you consider a point will be here and if you consider a circle like this one, then within this one the mass will be same. So what is changing actually? What is actually changing? The distance is changing. What is a new distance? Earlier it is r distance, now it become r plus h the whole square. R plus h the whole square. So what we will do? We will do some Gm divided by r is taken outside, so it become r square 1 plus h by r the whole square. What is Gm by r square? Gm by r square is called gravitational field intensity. So G dash will be equal to G divided by 1 plus h by r the whole square. This is a very important relation. This is important. Okay, this is important. G dash equal to G divided by 1 plus h by r the whole square. So for further simplifications, I am going to do the further simplification. This is important. Okay, and this is I am giving equation number 1. So this equation number 1 I am further rearranging 1 plus h by r the whole raised to minus 2. There is a mathematical relations will be there. 1 plus x power n when x power minus n, for example 1 power x power minus n, when mod x the value is less than 1. If it is less than 1, if it is a very less value, then you can write it as, you can write 1 plus x raised to minus n equal to 1 minus nx. This is a fundamental principles in mathematics. If you don't know, you have to write this one. 1 plus x raised to n, when mod x less than 1, 1 plus x raised to minus n equal to 1 minus nx. So x less than 1, x 1 inekal kammi, less avanam. So in order to have less, h value should be higher or lesser. H should not be equal to r. If h is equal to r, you will get h, r by r, you will get 1. No, it's not possible. H is less than r. If h is less than r, if h is very much less than r, you know h by r is less than 1. H by r is less than 1. If h by r is less than 1, if you compare this equation, 1 plus x, instead of x, what is there? H by r. If that is less than r, then you can write 1 minus nx, which means g dash equal to g into 1 minus nx. 1 minus n is 2, so 2x, so 2h by r. So this is also important. This is also important. This is my second equations. So I have given you the two equations. Variation of g due to the height. So g is equal to gm by r square at the surface of earth. When you are going above the surface of earth, g dash will be equal to g divided by 1 plus h by r square. This is important. This is equation number 1. Similarly, while we are solving, if h is less than 1, suppose in the examination, while you are doing certain questions, if you are very much sure about that, you are okay. Suppose if they are asked you to find out the value of h, then you have to use this equation, because why? You don't know what is the value of h. If they are given the value of h to you and you get to know, okay, the value of radius r will be here. The value of this radius is 6,400 kilometers. If h value is given a very less value, then you know h is less than r. If you know h is less than r, then you can use this equation. So I am saying you can use equation number 1 and equation number 2 interchangeably in question. It is depends upon the question. If h value they ask us to find out, then you have to use this equation. If you know h value is very less than that of r, then you have to use this one. So we will write an equation. So use 1 to find h. For example, to find h, use equation number 2. If you are sure about, if you are sure about h is very much less than r. If h is very much less than r, you are feel free to use equation number 2. If you are not sure about that, you have to use equation number 1. So this is very clear, right? We will do one questions over here. Okay, then this will be get clarified. Fine. Okay, so let's move to do one question. So the question is, here it is, the question. Find the height above the earth surface, where gravitational field, where the acceleration due to gravity, falls 36% of its value from surface, Find the height above the earth's surfaces where the acceleration due to gravity falls 36% of its value from the surface. 36% value is reducing. Acceleration due to 36% reducing means what is that? 64. Suppose your value at the earth surface the gravitational field intensity value is 10 meter per second square at the surface. 36% reduced means what will be there? 64%. 64% which means 64 divided by 100.64. Now if you calculated the surface 10, adinte 36 reduced if you are going to height, so what will be their value? 6.4. So at what height, question is asking at what height you are getting the acceleration due to gravity value reduces by 36%. 36% ആയിട്ട് g drop to 36% of, okay, we'll make the question like this: 36% of its surface, which means I will make the questions very clear, do not confuse. Find the height above the earth surface. We need to find height where the acceleration due to gravity falls 36% of its surface. If a surface 10 value on 10 meter per second square. Now after some time something is going on, mass is going above, and I am measuring the acceleration due to gravity. I get to know which will have 3.6 value. 3.6 value means 65% it is reduced. Now 36% value remains. That's the question. Where the acceleration due to gravity falls to 36% value. So 36% ആണ് ഇപ്പോൾ ഇരിക്കുന്ന അതിൻ്റെ വാല്യൂ. Now the current value is 36%. അതൊക്കെ how much height I have to go? That is a question. So height we don't know. So g into 1 plus h by r the whole square. So the new value is 36% of g is equal to g divided by 1 plus h by r the whole square. It is drops to 36%. It's dropped to 36%, which means now 36% remains. 64 reduced drops to final 36%. 64 reduced. So this was the equation. 36% of g, which means 36 divided by 100 into g is equal to g divided by 1 plus h by r the whole square. G and g get cancelled. I am taking the reverse in both sides. So 100 divided by 36 percentage 36 by 100, 7% 7 by 100. You know, right, from maths. 1 plus h by r the whole square. Two sides square root we have taken. So 10 by 6 is equal to 1 plus h by r. So we'll do some stuffs. So 10 by 6 minus 1 equal to h by r. So this become 10 minus 6, 4 by 6 is equal to h by r. Going forward. So 4 by 6 2 by 3. 2 by 3 is equal to h by r. H is equal to 2r by 3. So above the height, earth surface, which means at a height of 2r by 3 height, its value reduced by 64% and reaches to 36%. So it is falls to 36%. Now the value is 36%. So at a distance of 2r by 3, which will have the value 36.3 will be available. Okay, hope this is very clear to you. Good. Okay, we'll move to the next question. Not next question, the next topic, the second one. So acceleration due to gravity will be changes in 4 contexts, as I told, right? One is due to height, another one is due to depth, rotation of earth, then shape of earth. Okay, so the second one, we'll move to the second one. Second one, variation of g due to depth. Variation of g due to depth. Okay, so here we have we'll see we have an earth will be here at a distance of d depth away. We'll have this point, so we'll come to this point. So total radius is r. So what is the balance radius will be here? It is r minus d. So this is a point. So we are coming at a distance of d meter down the line. We are coming d meter down the line. So we know the gravitational field intensity here is equal to gm by r square. We want to find out what is the gravitational field intensity value will be here at this point. So we will see. Okay. So we know g dash will be equal to mass. Now the full mass of earth is m. We don't have the full mass. Now we are here. So within this one, only this mass will be remains there. So this mass is given as m dash. So we'll give gm dash divided by the distance r square. So what is the distance to that point? R minus d the whole square. So how to find out the mass? So we know 4 by 3 pi r cube area will have m kilogram mass. R is the full radius. Okay. So both sides 4 by 3 divided. So 1 meter cube will have m divided by 4 by 3 pi r cube is the mass. Our radius is r minus d. So r minus d is this much area. R minus d. So this r minus d will have 4 by 3 into pi into r minus d the whole cube will have a mass of m divided by 4 by 3 pi r cube into 4 by 3 pi into r minus d the whole square. 4 by 3 pi cancel, 4 by 3 pi cancels. Okay. So what is the mass? M into r minus d the whole square divided by r cube. This is the mass available. We are substituting similar to what we have done before only. So g into its mass, e area into mass on, because we are here, we are not here. If we are here, gm by r square. We are here means it's not gm by r, gm into m dash. Mass we have to see for this area. So gm divided by r cube into r minus d the whole square, whole divided by r minus d the whole cube, r minus d the whole cube divided by denominator r minus d the square. 4 by 3 pi into r minus d whole cube, left side multiplied, right side multiplied. So cube രണ്ട് സൈഡിലും cube. So r minus d the whole cube whole divided by r cube. അതാണ് m dash. ഈ mass, this mass we call it as m dash. So this is nothing but m dash. So m dash we are substituted r minus d the whole cube divided by r minus d the whole square. Okay. Now we have these values and we have to make sure that what's going on will be here. So we got these values. So we know what all things will be getting cancelled outside. I am clearing this area. So you can pause the video and you can write these notes. Okay. This is the main advantages of online classes. If it is a class means I have to wait, everybody has to write the notes. But if it is online class, it will be very fast, because whenever you want you can go back and you can write the notes. Okay. So let's simplify. R minus d will get cancelled out, will be each other. So what is coming for us? Now g dash will be equal to gm into r minus d whole divided by r cube. R minus d whole divided by r cube. We have this equations. Okay. R cube, it's nothing but the radius gm divided by r cube. Now we'll see, this can be written as gm divided by r square into r minus d divided by r. So this will be equal to g, we know. This can be written as r by r 1 d by r g into 1 minus d by r. This is the gravitational field intensity at a depth d, or below the surface of. Okay. So when you come to the center, okay, this is the acceleration due to gravity at a depth d. D from where? D from the surface. Surface nu keela d distance away gravitational field intensity value is this much. Now at the center, next point, at the center of earth, at the center of earth. At the center of earth means from where? Now we come at a distance of d. Now if you are coming to the center means how much distance we have to come? D is equal to r meter away we have to come to the center. In that cases g dash will be equal to g into 1 minus r by r, which is equal to 0. So acceleration due to gravity at the center of earth will be equal to 0. So weight of a man at the center of earth, this will ask us a question, at the center of earth is equal to mg, which is equal to m into 0, that is equal to 0. So a man should not wait at the center of earth. Okay, weight of a body is equal to mg, that's all. Weight of a body is equal to mg and g is equal to 0 at the center of earth. So there is no weight at the center of earth. Okay, hope this is clear. And we will draw a graph for the variation of acceleration due to gravity. So we will draw, we know from this equations g dash is proportional to r minus t. So for this case we will draw a graphical representation of g. Okay, graphical representation of g over a distance of. Now if you see r minus d means this distance. Okay, r minus d means this is called r minus d. So if r minus d is increases, which means if I am going from this area towards outer area, r minus d increases, which means now this much d, if I am here means d reduces, here means d reduces, here means d reduces. So d becomes smaller if I am going from center to outside. So if r minus d is higher, so I'll write r minus d is increases, g dash increases. So I can say r is the distance from the center. So r minus d is the useful area. D should be lesser. So if r minus d increases, then g dash is proportional to r minus d. So once we reaches to the center, once we reaches to the surface, if you reaches to the surfaces, what is the value of d? Okay, so let me take some area. So g dash is proportional to r minus d. This is very clear. When r minus d increases, what will happen? When r minus d increases, g dash increases. Okay, next, at the surface, if you are reaching on the surface, so d is reducing. Now I am going from the center, little bit, I am going towards the center. So d is reducing, r minus d is increasing. When I am at the center, depth is equal to 0. There is no depth. So only the radius. So g will be equal to gm by r square. So g will have some maximum value, g at the surface. Then g will be reduced. So g is proportional to 1 by r square. 1 by what r square? I mean, if you are going out of the earth surface, then r plus h the whole square. So g dash is proportional to r minus d within this one, and this is at a surface area. So at this surface, depth equal to 0. There is no depth. After the surface you are going outside, so g is equal to gm by r plus h the whole square. Denominator increasing, g dash reducing. In what fashion? Parabolic fashion, because it is directly linked with the quadratic equation. Okay, so hope today's session is clear to you. We learned mainly 3 topics: acceleration due to gravity for a solid sphere, acceleration due to gravity, variation of acceleration due to gravity depends upon the 4 factors. Out of this, 2 factors I have discussed. Next class I will discuss the next 2 factors. So remember, variation of g due to height, variation of g due to depth. 2 more topic left under this. Next class topic, variation of acceleration due to gravity due to the rotation of earth, due to the shape of earth. Hope that today's session is useful to you and you get some new informations from me. Thanks a lot for watching the video.